Welcome you all. In this session we are going to discuss the operation of multi-stage impulse generator. After successful completion of the session, the student would able to explain the operation of multi-stage impulse generator. Multi-stage impulse generator or Marx circuit. It is otherwise called as Marx circuit. First, let us see the difficulties in encountered for single stage impulse generator, because in single stage impulse generator the capacitance C1 is charged first and discharged the wave shaping gap or circuit. Above 200 kilovolt generation, charging unit cost is high in case of single stage impulse generator, and the size is more. High DC voltage is needed to charge the capacitance. So these are the various difficulties or limitations we have in single stage impulse generator. For this we are switching to multi-stage impulse generator. So these are the various drawbacks we have. The voltage to charge C1, and the last but not least, the difficulty of suppressing corona discharge from the structure and lead during the charging period make the one stage or single stage is inconvenient for higher voltages. In order to overcome these difficulties, Marx in 1923 suggested an arrangement for charging the capacitor in parallel through high ohmic resistor and discharging it in series with a spark gap. So while charging it has parallel resistor and discharging it has a series resistor. So this format was proposed by Marx, hence we call them as Marx circuit or multi-stage impulse generator. The schematic diagram of a multi-stage impulse generator. Here you can see the G1, G2, G3, G4, G5, G6. These are the gaps. So while charging, these gaps are open circuited. So all the capacitors are connected in parallel. So they forms a parallel capacitance, and with resistors are also parallel. When during discharging time, arc forms between this gap. Arc takes place in this gap. So these gaps are in closed state. So at this point here you can see while discharging the series through this spark gap. So the resistors are connected in series format, and here the R2 R1 dash, these are the resistance. These are all called as the charging resistance, whereas this R1 that is connected at the load end, this resistor R1 is called as the wave shaping resistor. It is called as the wave shaping resistor. And the test object, if the main use of this impulse generation is to conduct impulse test most probably. So if you want to go for impulse testing, then the test object need to be connected across this capacitor C2, and the voltage, the maximum voltage you can take place across this capacitor C2. So the basic components we have in this multi-stage impulse generator are DC charging set, charging resistors. Usually the charging resistor will be in the range of 10 to 100 kilo ohm, and voltage across the charging resistor will be in the range of 50 to 100 kilovolt. Next we have the generator capacitor and spark gap, and the final component we have is the wave shaping resistor. So these are the components we have in multi-stage impulse generator. As point B is still the remaining charge potential of V, thus the voltage of 2 volt would appear across G2. This high voltage would therefore cause this gap to break down, and the potential at the point I would rise to C2V, creating a potential difference of 3 volt across gap 3. So at on increasing each stage, the voltage will be also increased. So according to this, even based on the size of capacitance and the resistor we used, we can improve. If the capacitance equals to 0, then the voltage across G2 will reach a maximum value of 2 volt. This gap capacitance however cannot be avoided if the stage capacitance C0 and this C0, C double naught, these are the number of capacitors connected in each stages, they have been represented. and V2 will be equal to V. The sparking gap is not possible. If the first gap is not triggered, then consequently the firing stability breakdown. So without triggering the first gap, we can't go for next one. Thank you.